Alright, so for my oral homework, I'm going to be going over a set theory proof where we let this fancy A here equal a family of indexed sets where we see that this alpha subscript denotes the indexes within the triangle indice set. And we're also going to let B be a set here, and what we're out to prove is that the union of a set B and the intersection of our index set is going to be equal to the intersection of the alpha within the indice set of B, or as in the union of B and A subscript alpha. So the strategy for proving this is, first we need to denote an element X is within our set B unioned with the intersection of our alpha within the indice family of A subscript alpha. And essentially we're just going to follow the set logic down the stairs to get to the right side of our quality up top here. So this is true if and only if X is within B by definition of union, or our element X is within the intersection of our indexed family of sets here. So basically we just have to break apart what these statements mean so that hopefully we can assemble to get to the right side of our equality here. So this is true if and only if X is still within our set B, and pulling apart the definition of the intersection here, or there exists an X within a distinct set within our indexed set for all alpha values within our indice family. And so breaking that apart further, we can take this statement here and put it up front. So this is true if and only if for all alphas within our index set family that X is either within B, or an X is within one of, for all alpha subscripts in the index family set, that X is within each alpha subscript set. So for every A subscript alpha in our index set, we have that our element X is within that, or X is within the set B. And so what we can do with this definition is, this is true if and only if, again, for all alpha subscripts within the index family set, that we can notice the or here, we can flip that to a union because that's literally what or means. So if and only if for all alphas within the index family of sets, the element X is within, we can get our parentheses, the set B, or a set A alpha. And so really all we have to do at this point is clean up and get this to look exactly what we want to get. So, following the logic of this is true if and only if an element X is within, because by definition of for all alpha subscripts within the index family of sets, X is within all of those. So the intersection of alpha within delta of B, or set A alpha. And so we have finally reached the right side of our equation here, following a logical series of steps, basically just translating from the left side here all the way down into the right side. And so with our final statement here that we have the element X within both this equality on the left, and X is an element within the quality on the right. Therefore, B union the intersection alpha within the index family of sets is equal to the intersection of alpha within our index family of sets of the set B or all alpha subscript sets within the family of sets. And that is the end of our proof.